reminds me of the part in your book where you said, I'm going to probably goof this up, but it was on one page of a medical textbook that talked all about how to, get fat out of the body. Yet on the exact same page, it said that fat accumulation is a calorie problem. And it almost, if I'm not mistaken, it never really occurred to the person who wrote it when you interviewed him several years ago. Is that right?
Yeah, this was wasn't actually the same page, same chapter. The sort of leading researcher in fat metabolism or even human physiology, a very, very nice man at Oxford University in the UK who did a lot of this research. And I feel bad targeting these people, but every once in a while, it's like you've just got to make this point on occasion. So I was interviewing him about all of this. This was around 2009. It was for an article I was doing for the journal Science on this insulin resistance condition. And he spent 20 minutes in the interview talking to me about, what seemed like 20 minutes, talking about all the various ways that insulin was the principal regulator of fat metabolism, all the effects it did on different enzymes in the fat cells. And then we got to obesity, and he said, well, yeah, people eat too much. I said, wait, professor, hold on 1 second. 20 minutes ago, we were talking about what makes a fat cell fat. And it was all insulin, all the different ways that make a fat cell fat. And now we're talking about what makes a human fat. And the obese human is just a compilation of all his overstuffed fat cells. And now suddenly we're talking about this eating too much thing. And these are different mechanisms. We've got the fat cell responding to insulin, but all the fat cells together responding to eating too much. And he literally said, I never thought of that. And they never really did. It was, like I said, from a journalistic perspective, if nothing else, it was stunning. Even if this hypothesis is dead wrong, this idea that since insulin is the principal regulator of fat metabolism, and in order to get fat out of fat cells, the quote from the same 1965 lecture by the people who developed the technology allowing insulin resistance in the body, insulin in the body to be measured. They said, the insulin response, what they call it, the fat cells respond to the negative stimulus of insulin deficiency. That was a technical term, and I use it in the book. That means your fat cells release fat into the bloodstream when they don't see the presence of insulin. So there's another phrase that's used often, even in the journal articles, is that fat tissue is exquisitely sensitive to insulin. If it can detect any insulin at all in the circulation, it's going to hold on to its fat because that insulin is there in theory in response to the carbohydrates that need to be burned, used for energy. So if nothing else, this was a viable hypothesis that the principal regulator is insulin. If there's any insulin in the circulation at all, your fat cells are going to hold on to fat. Therefore, there should be a carbohydrate insulin model saying, look, we get fat because the carbohydrates in our diet. And all of this was until the 1960s, the conventional wisdom was that carbohydrates were fattening. Every woman knew this. That was a line that I quote in every one of my books from the 1963 British Journal of Nutrition article written by one of the top 2 dietitians in the UK. And the first sentence was, carbohydrates are fattening. Every woman knows that carbohydrates are fattening, something like that. This is a piece of nutritional wisdom that no one would dispute. They go on to dispute it. But the fact that was a conventional wisdom until then, and in the 1960s, they actually learned why this could be true. And then they never study it because they know why people get fat, they eat too much.
Yeah, it's bonkers. Why they couldn't even question it, explore it. It's absolutely crazy. It's so crazy.
Well, then there was another thing, getting back to Ansel Keys just for a second. See, that once we embrace the idea that dietary fat caused heart disease, then the idea is we have to eat low-fat diet. So we replace the fat with carbohydrates. So the carbohydrate, which until the 1960s had been considered uniquely fattening, after the 1960s was seen as heart healthy diet foods. So now, if you examine this possibility that carbohydrates are fattening through their action on insulin, well, you can't do that because we're telling everyone to eat carbs because we think fat causes heart disease. So, and this is the problem with embracing these hypotheses before they're rigorously tested. And once you do, you lock yourself into a whole way of thinking about a whole host of things you never imagined. The diabetes book is basically yet another way that all of this science, pseudoscience I'm discussing, perverted dietary therapy for what's now like 1 in 7 adults. I mean, it's crazy.
Yeah, absolutely crazy. You mentioned earlier people being obese or overweight as, we think of that as it's a willpower problem, it's a character problem. But you talked about something that I thought was absolutely fascinating that never really occurred to me. And it is the cephalic phase of insulin secretion. And, I kind of understood that, but understanding the point that, I can walk through a mall and smell Cinnabon, and it might not like really affect me. Where somebody who is overweight, it might affect them completely differently in a way that I could never really experience. Can you talk a little bit about that? I think that was fascinating.
Okay, so there is this concept called the cephalic phase of insulin secretion. You could think of it as the term we're used to thinking about is Pavlovian responses. So Pavlov's this Russian scientist in the early 20th century who demonstrates that he could train his dogs to associate the ringing of a bell, I think it was, to eating, and then he could ring the bell and the dog would start to salivate. So this is a Pavlovian response. The salivation was preparing the dog for eating, which he now associated with a different phenomenon entirely. So it turns out our bodies do that in a host of different ways. Our bodies, eating food is we've just evolved with very sophisticated, complex, almost miraculous mechanisms to take in this food and process it in a way that maximizes health in the short term and prepares us for any exigencies in the long term. So one of these is insulin secretion. You start thinking about food, you secrete insulin. In response. It's actually, and the way it was first described to me by a famous physiologist at the University of California, San Francisco, had done a lot of this work in the early 1960s, is you've got an engineering problem, which is that it takes insulin time to start working on the cells, but the blood sugar starts going up immediately. And once the insulin reaches peak value, it's going to continue working even after the blood sugar starts coming down. So your body, one way your body deals with that is by you start secreting insulin before you eat. So it's already working when the carbohydrates hit the bloodstream and your insulin starts going up, and then you kind of secrete it in pulses so that you never have this problem where you have too much insulin and the blood sugar is already coming down and now you're out of balance. This cephalic phase is interesting because if you're insulin resistant, this condition we talked about where your cells don't respond properly to insulin, which is almost assuredly the case if you're overweight or you suffer from obesity or type 2 diabetes, it's certainly the case, then you're going to oversecrete insulin. And if you oversecrete insulin in the cephalic phase, which is thinking about food, stimulates insulin secretion, and now you oversecrete it, that insulin is going to make you hungry. Basically, it tells your fat tissue to hold on to fat. It tells your lean tissue, your non-fat tissue, to take up blood sugar and burn it for fuel, but your blood sugar is not going up because you haven't eaten yet. So you start emptying the bloodstream of fuels and your cells start to sort of starve a little bit, and your liver probably plays a particular role in here, and all that's going to make you hungry. So now you imagine two people walking through shopping mall. This was the example I use in the book. One is lean and not insulin resistant. The other suffers from obesity and is insulin resistant. And they smell the Cinnabon. Cinnabon is a great example because I'm convinced they have fans that blow the smell of the freshly baked Cinnabon into the mall or the airport or wherever you are, because they know that people are going to smell it and want to eat a cinnamon bun. This is the some of the physiology underlying that. So the lean person smells the cinnamon bun, and he's got this very modest, if at all, insulin response. And it's very easy for him to say, yeah, a cinnamon bun, I'm not that hungry. Let's keep going. Now, the person who suffers from overweight or obesity and is insulin resistant has a much stronger insulin response. And that insulin response makes him hungry. And because insulin is signaling the cells to take up carbohydrates and use it for fuel, it actually makes him hungry for carbohydrates. So for that person, he's now in the midst of his, Ansel Keys starvation experiment from the 1940s. And he's getting hungry and hungry, and all he wants to eat is a cinnamon bun. So he goes into the store and eats a cinnamon bun, buys it, walks out of the store. He's eating the cinnamon bun, and some other lean person is walking by thinking, aha, that's why he's fat. He's got no willpower. It's got nothing to do with willpower. It's purely physiological. And one of my speculations, and I can't prove this, is that lean people cannot understand this phenomenon because it doesn't happen to them. Their bodies don't work the way ours do. So it's like the whole concept of willpower is a lean person seeing other people eat and thinking, I don't eat like that, therefore I have better willpower. But they can't understand it because we're not them. Our physiology is different. Our body is responding differently. How that response manifests itself as hunger is different. And unfortunately, it all comes down to this. If you can minimize insulin secretion, which you do by not eating carbs and replacing the calories with mostly fat, then you can slowly fix all this, and then your body will work kind of like a lean person's. And a year from now, hopefully, if that same two people walk through the shopping mall and one of them, was always lean and the other one is newly lean, but now eating a ketogenic diet, the cinnamon bun won't affect him the same way.